Hello, I'm Mrs. Burns, and welcome to Lesson 7 of our Fractions chapter. Today we are on 6.5, Dividing Fractions and Mixed Numbers. So when dividing fractions, you need to switch the second fraction upside down and multiply instead. We call this multiplying by the reciprocal. So the reciprocal is basically just the opposite of the fraction. So when you flip a fraction upside down, so 3 over 4 to 4 over 3, if you multiply those together, the product always equals 1. Remember that one number divided by itself is always equal to 1. So that means 3 over 4 and 4 over 3 are reciprocals. Let's find these reciprocals. 2 over 3, the opposite would be 3 over 2. 7. Well, remember that 7 is really just a secret fraction. So 7 over 1 would be 1 over 7 is the reciprocal. And 2.5, well, first we need to change this to an improper fraction. 2 times 2 is 4 plus 1 is 5 over 2, so the reciprocal would be 2 over 5. Wonderful. So there are some instructions about how to divide using a common denominator in section 6.5 of your book. However, we are going to use that multiplying by the reciprocal method today. So when you're dividing a fraction, remember that any whole number needs to be written like a secret fraction, and any mixed number needs to get changed to an improper fraction first. Then, just like normal, we multiply the numerators, we multiply the denominators. Then we switch the fraction upside down and multiply the reciprocals so that we can multiply the numerators, the denominators, and again, just reduce to lowest terms, thinking what number can both the numerator and denominator be divided by? Let's look at some examples of this. 2 over 3 divided by 1 over 4. First, we don't have any whole numbers or mixed numbers, so we can just multiply by the reciprocal. So this equals 2 over 3 times 4 over 1. So we flipped this guy upside down. 2 times 4 is 8, 3 times 1 is 3. 8 over 3 can't be reduced any further, so we can leave it like that, or we can express our answer as a mixed number. 3 goes into 8, 3 times 2 is 6, plus 2 left over, keep the same denominator. All right, number B. This would be the same as saying 1/3 times 6 over 5. Multiply our numerators, 6, denominators, 3 times 5 is 15. Can we make this reduced any further? Yes, we can. They can both be divided by 3. 3 goes into 6 2 times, and 3 goes into 15 5 times. So our answer is 2 over 5. In this case, 1/2, we'd multiply by the reciprocal. The reciprocal would be 8 over 5. 8 times 1 is 8, 5 times 2 is 10. Can this be divided by the same number? Yes, they can both be divided by 2, and we will get 4 over 5. That cannot be reduced any further. And our last example on this page, 3/8 divided by a quarter could also be expressed as 3/8 times 4 over 1. 3 times 4 is 12, 8 times 1 is 8. Both 12 and 8 can be, divided by 4. 12 divided by 4 is 3, 8 divided by 4 is 2, or you can say 3 over 2 as 1.5, because 2 goes into 3 one time for one whole number plus one remaining, same denominator. All right, let's look at this as word problems. Gabriel got 5/6 of the quiz questions correct, and he got 15 questions correct. So how many questions were on that quiz? Well, if he got 15 correct, and there were 5/6, then we could say 15 divided by 5 over 6 is the same as 15 over 1 times 6 over 5. 15 times 6 equals 90. 1 times 5 equals 5. Both of these can be divided by 5. 90 divided by 5 is 18. 5 divided by 5 is 1. So 18 questions total were on that quiz. So I'd say Gabriel did pretty well on that quiz. David walked 4.5 kilometers in 1.25 hours. If he walked at a steady pace, how fast did he walk in kilometers per hour? So he walked 4.5 kilometers in 1.25 hours. Uh-oh, these numbers are mixed numbers. We need to change them to improper fractions. 4 times 2 is 8 plus 1 is 9 divided by 2. 1 times 4 is 4 plus 1 is 5. We can rewrite this as a multiplication statement. 9 over 2 times 4 over 5. 9 times 4 is 36. 5 times 2 is 10. Both of these numbers can be divided by a certain number, and we know that both of these are even, so if nothing else works, we can always go down to 2. So we get 18 over 5, or you can say, because if you said, oh, how fast did he walk in kilometers per hour? He walked 18 over 5 kilometers per hour. Let's say it like a mixed number. 3 3/5 kilometers per hour. Well, that's pretty quick, David. And example 3, a running track used in a competition is 2/5 kilometers. How many laps is the 1,500-meter race? Now, one thing you might notice is that we have kilometers and meters in the same question. So we need to make sure that our units are the same. So here's a hint. There are 1,000 meters in 1 kilometer. So if we say 1,500 meters equals how many kilometers? We know that there are 1,000 meters per kilometer, so let's divide by 1,000, and we see that there's 1.5 kilometers in 1,500 meters. 1.5 kilometers divided by 2/5 kilometers. We can rewrite this a mixed number as an improper fraction. 2 times 1 is 2 plus 1 is 3 over 2 divided by 2/5 is the same as 3 over 2 times 5 over 2. 3 times 5 is 15. 2 times 2 is 4. And we can say that there are 15 over 4 laps, or we could say that 4 goes into 15 3 times. 4 times 3 is 12. 13, 14, 15. So 3 3/4 laps. All right, there you go. You have just mastered section 6.5, dividing fractions and mixed numbers. You are now ready to move on to section 6.6, applying the order of operations to your fraction problems.